Hello students, welcome to the class. We will continue our discussion with the geometrical optics. We have already seen the plane mirror. We have seen that we were in the spherical mirror, so that only I will continue. In the last class about the focal length and radius of curvature relationship, I have given you the relation f is equals to r minus r by 2 cos theta. I hope you will be remembering this relationship. This is actually not focal length. Focal length, if I write this f is equals to r by 2, then it is focal length. When theta tends to 0. So there are two types of rays. For one, which is theta is not nearly 0, and other ray for which theta is nearly 0. So if theta has the large value, then such rays are called marginal rays. And if theta has very small value, then such rays are called paraxial rays. Now, this focus is defined for paraxial rays only. If I am taking a mirror concave and this ray is very far away from the principal axis, then it will pass through this point. Here the center of curvature is there. This line will behave as the normal. So this theta is not equal to 0. It is not nearly 0. Whereas, so this ray is basically your marginal ray. And on the other hand, if I take this ray which is near to principal axis, then you see here the normal will be something like this, and theta is nearly equals to 0. Theta is nearly equals to 0 degree. Then it will pass through a longer distance, and this point is giving you the focus. So if the distance goes on increasing from the principal axis, the reflected ray starts shifting towards the pole. So this is marginal ray, and this ray which is near to principal axis is called paraxial ray. For this relation, we are considering only paraxial ray, and this is the relation for marginal rays. Now what I would like to tell you, suppose I am giving you an example that here is a concave mirror and here is the center of curvature, and an object of 5 centimeter ray is incident parallel to the principal axis, and the radius of curvature, this radius of curvature of this is your 10 centimeter. After reflection, this passes through a point F. Now this distance, if it is x, x is equals to how much? Generally the student understands that this is the focus. So he will immediately give the answer f is equals to r by 2, that is radius of curvature by 2, that is 5 centimeter. But 5 centimeter is not the answer. Why? This angle theta is not negligible. This angle is theta because this is normal. So this angle is also theta. So this angle is also theta. Now you see, if I drop a perpendicular here, then tan theta sin theta is equals to perpendicular by hypotenuse. So perpendicular is this distance 5 centimeter, 5 centimeter by 10 centimeter. Base is your hypotenuse is your 10, because this is your radius of curvature, so this is also radius of curvature. CP is the radius of curvature, so this is also radius of curvature. You see, it is also radius of curvature. So 5 by 10, 1 by 2, that is sine 30 degree. So theta is equals to 30 degree. This is not equal to 0, not nearly 0. So what we have to do? Can we use the formula f is equals to r by 2? So therefore f is not equal to r by 2. Why? F is equals to r by 2 is valid for paraxial rays where theta is a small, and here theta is not a small, it is 30 degree, it is not a small. So we cannot use this formula. This formula we cannot use. Then what formula we have to use? We have to use this formula. So this is r is equals to how much? 10 centimeter. 10 minus 10 by 2 cos 30 degree. Theta is equals to 30 degree we have got. So 2 cos 30 degree. So this is giving you 10, 1 minus 1 by 2, cos 30 is root 3 by 2. This will cancel and you are getting 10 into root 3 minus 1 by root 3, that is 10 into 1.732 minus 1 by root 3, or whatever is the value, this much centimeter. You calculate and you will be getting the answer. This value will give you the answer. Certainly it will be not f is equals to r by 2, that is 10 by 2, that is 5 centimeter. It will not be equal to 5. It is not equal to r by 2, that is not equal to 5. You will check. So this is an example by which I want to make you feel that when you have to use f is equals to r by 2 and when you have to use f is not equal to r by 2. If this is 5 millimeter, then and if it is 5 millimeter, then you can use this formula, because 5 millimeter is negligible in comparison to this, but 5 centimeter is not negligible in comparison to the distance radius of curvature. So this example will help you in getting the concept that what is paraxial ray, what is marginal ray, how for paraxial ray this formula is valid and how for marginal ray this formula is valid, and this example will be helpful in clarifying the concept regarding this one. Generally, focus is defined for the rays which are paraxial in nature, and I have discussed in the last class that which are parallel to the paraxial rays and parallel to the principal axis, they after reflection pass through the focus. Now it is not always that the rays are parallel to the principal axis. Here also it is coming from infinity, but it is possible that the rays are parallel but not parallel to the principal axis. For example, I am telling you, here you see it is your principal axis. These are the rays, they are parallel, they are also coming from infinity, but they are not parallel to the principal axis. Such rays will meet in focal plane. If this is the focus, then here will be a plane, and on this focal plane, this is normal. So keeping this angle equal, here it is going, and every ray will intersect at this particular point. That means here. Now the question arises, and what is this? This distance is your focal length, and this point is your F. So if the rays are parallel but not parallel to principal axis, then they meet at a point in the focal plane. Now what should be the height of this? What should be this distance? If this angle is theta, this angle is again your theta. So if we take tan theta is equals to h by f, perpendicular by base. So h is equals to f tan theta. Now here, to understand a thing, if theta is a small, sin theta is equals to theta, tan theta is equals to theta. So h is equals to f theta, but theta should be in radian. Theta should be in radian. So h is equals to f theta. One more thing here I would like to tell you. I will give an example also, that suppose and moon is there, and that moon is making an angle 2 degree at the pole of concave mirror. Now it is making an angle 2 degree at the concave of pole mirror, at the pole of concave mirror. So 2 degree, this we have got, of focal length, suppose 20 centimeter, so focal length 20 centimeter. Then what is the diameter of image? Find diameter of image of moon. In this situation, if we want to find this diameter, this will represent the diameter of the moon. Moon will be here only. So if we want diameter of image, h is equals to f theta. F is 20, theta is your 2 degree. So how we convert degree into radian? 180 degree is equals to pi radian. So 2 degree is equals to pi by 180 into 2. So this can be written as 20 into pi by 180 into 2. This will give you 0, 0 will cancel, 2, 9. So it is your 2 by 9 into pi meter. This will be 2 by 9 into pi meter because we are using the radian. So it should be 2 by 9 into pi meter. So, and this should be by 100 meter, then it should be 2 by 9 into 100 into 100, that is 2 by 9 into pi centimeter. This will be meter, so it will be in centimeter. So what I mean to say, this type also the questions can be framed using the concept of focal plane. So this was the question related with the concept of focal plane. One more concept I would like to introduce with you, that is the new concept for you, that in any triangle, if this is 3, this is 4, naturally this will be 5. If this is 3, this is 4, this will be 5, then without confusion directly remember that this angle is 37 degree. This angle is 53 degree. And this angle already is 90. This will be helpful to you people whenever, if this is 3 and 5, you can automatically say it as 4, and if it is 3 and 4, you can say it as 5. For example, I want to tell you, for example, I can give one example on this one, the same question. Here you see, suppose the concave mirror is there. Again, similar example I am taking. Here it is 3 centimeter. Here radius of curvature is 5 centimeter. This ray is going and it is passing through a point F. You have to say FP is equals to how much. Now again you cannot use F is equals to R by 2, because if this is the center of curvature 5 centimeter, then here you see theta is not small, and here you see this is theta, this is theta, this is theta. So this distance, if we want to find here to here, this is your 5 centimeter. Why? It is the radius of curvature. Now again we will have to use the same formula, F is equals to, now you see, here you see, this is 3 and this is 5. What does it mean? Theta is equals to 37 degree. Naturally this distance will be equal to 4. Here you see 3, 4, 5. Here 3 and 5 is given, so this will automatically become 4. Now if we want to use the formula Fp is equals to R minus R by 2 cos theta, then what will be the value of cos theta? Cos theta will be 4 by 5. So this will be 5 minus 5 by 2 into 4 by 5. 5 will go in the numerator, and so you are getting 40 minus 25 by 8, and this is giving you 15 by 8. So it is approximately 1.8 something centimeter. Now you see, according to F is equals to R by 2, 40 minus 15 is. So I want to say you that in this case the F is not equals to, this distance is not equals to FP. What does it mean? It is not equals to R by 2. That is the main objective, that F is equals to R by 2 is not always valid. You will check the calculation. If calculation mistake is there, you will correct it. And so what we are getting? We are getting that this way. We were discussing so we have understood the focal plane. We have seen some new concept regarding the diameter of image. We were explaining the rules for making the ray diagram. So I am continuing our discussion with ray diagram. Ray diagram. In ray diagram, we have seen that there are two situations. One is concave case. Concave mirror, the reflecting side is concave. This is reflecting side. And in convex mirror, this is reflecting side. This is convex. So this thing has to be kept into mind. Now we are talking about mirror of a small aperture. So here the F is equals to R by 2 will remain valid. What I mean to say here, that in case of concave mirror XPY, certain defined positions are there. One position can be at infinity, that you have read in your junior classes also, this ray diagram. One position beyond C, one position at C, one position between C and F, one position at F, and one position between F and P. F is your pole, P is your F is your focus, P is your pole, and C is your center of curvature. So these are the 6 positions in case of concave mirror that you have to understand. And in convex mirror, one position we can consider at infinity and one position will be anywhere between pole and infinity. So 2 positions are there. So in all together you have to remember the 8 ray diagram. Now quickly we should revise the ray diagram formation and then we should see. First, object is at infinity. If the object is at infinity, the rays should come parallel to the principal axis. The rays should come parallel to the principal axis, and naturally after reflection they will meet at a point on the focus. So what we can say here, the point of intersection of reflected rays is called image. So here we are getting the real image, which is very small. Point size is there because it is in the form of point. So real image and point size image formed on the focus of the concave mirror. In second case, you can see the convex mirror is there. Again the mirror is of a small aperture. In this situation, again the rays are parallel to principal axis, and then you will observe that here. In this case, the point of intersection of reflected rays is your point only, but it appears to meet at this point. So virtual image, point size at the focus of convex mirror XPY is formed. Here also point size image is there, here also point size image is there, but in this case the point size image is real in case of concave, whereas in this case the point size image is virtual. Second case you take, beyond C, the object is there, so ray parallel to principal axis will pass through focus rule, and one ray passing through center of curvature will retrace its path. So here you are getting the image, AB is object, A dash B dash is image. What we observe, real image is there, but this time the image is diminished, that is smaller in size, and the position is between C and F. If the object is shifted towards the center of curvature, the image will be shifting away from the focus. So this thing also you should keep in mind. And the third diagram is very common, that when the object is at center of curvature, the image is also formed at center of curvature. The image is, if the object is at center of curvature, the image is also formed at center of curvature. Whenever we are making the ray diagram, we are not violating the rules for making the ray diagram. We are not violating the rules for making the ray diagram. Now here a very interesting, so object is at center of curvature, image is also at center of curvature, it is of same size, it is real, and real image is inverted, that you have already seen, it is inverted in nature. What next I would like to tell you, here a very important question comes for your understanding. What is the minimum distance between object and its real image in case of concave mirror, in case of spherical mirror? So object is here also, image is also here, so minimum distance is what? 0. So this thing I will write as a note, this thing I will write as a note, the minimum distance between object and its real image is 0 in case of concave mirror. This thing has to be remembered. For understanding the concept, you should understand. Here see, this is the distance. Object here see, it is infinity. Here also it is infinity, because image is here, object is at infinity. Object is at infinity and image is at focus. And here object is here also and image is here also. So the distance between object and image is 0. Object and image is 0. Where the object is there, there only the image is being formed. So we have seen these cases. So altogether we have to see 6 plus 2, 8 ray diagram, 1, 2, 3, 4 we have seen, 4 more diagram I will discuss with you people. Now after discussing the object at center of curvature, we have to discuss that object is now placed between focus and center of curvature. Here if we keep the object according to rule of ray diagram, the ray will pass in this way. One ray, according to rule of ray diagram, after passing through focus will pass in this way, and here we are getting magnified image. So AB is object and A dash, B dash is image. So if the object is between center of curvature and focus, the image is formed beyond center of curvature, which is real and magnified. Magnified means bigger than the object. Next case is that if the object is at focus itself, if the object is at focus itself, one ray parallel to principal axis will go in this way, one ray will go center of visible rays, and here you see they become parallel. They become parallel. So in this case, highly magnified image is formed at infinity. Now you cannot say it is real or virtual. From this side, if we will observe, we will say it is real, but from this side it will be virtual. So this thing we have to discuss later on, that when we have to take real, when we have to take virtual. Here only you have to understand that if the object is at focus of the concave mirror, then highly magnified image is formed at infinity. If you are moving from this side, naturally it should be real in nature. If you are moving from this side, it should be virtual in nature. So we will discuss this thing in detail. Next case is there, 4 to 6 is there, 2 more diagram is there. Next case is there, if the object is between focus and pole x, p, y, then you will observe that a virtual image is formed behind the mirror. Virtual image is formed, this is OAB and this is A dash, B dash. So virtual image is formed behind the mirror, which is magnified, and this property of concave mirror is used by the dentist. So dentist uses this mirror for seeing some problems of the teeth, some decay in the teeth and other things are there. Also the shaving mirror is also this concave mirror. We will be utilizing this property of concave mirror as the shaving mirror. So I should write shaving mirror and concave and dentist mirror. Shaving mirror and dentist mirror is basically your concave mirror. Next thing is there to understand is the last diagram about convex mirror. So here you see, in convex mirror, if the object is anywhere between pole and infinity, we will be getting the image center of curvature. Here you see, we are getting a virtual, this is object, this is image. So we are getting a virtual diminished image. See, image we have seen diminished image between pole and focus. All the time you will be getting the diminished image in case of convex mirror. So if you analyze the image, which image? Virtual. if you analyze the image, it is of three types. One is same size as formed by plane mirror. One is magnified as formed by concave mirror, and one is diminished as formed by convex mirror. Also, one thing is there that you have to understand: the field of view in which the image is seen by the observer. So the field of view of convex mirror is very large, and at the same time the image is always formed between pole and focus. Therefore, this mirror is used as the rear view mirror in the vehicle. This is used as rear view mirror in vehicle. Rear view mirror in vehicle: car, motorcycle, bus, truck, etc. It doesn't mean that aeroplane. In aeroplane there is no reverse gear or reverse back thing, no need of seeing. So it is not used in aeroplane. It is basically in rear view mirror in your car, motorcycle, bus, truck, etc., micro, whatever you see. So this is the ray diagram, and this practice and remembrance of ray diagram is very important for you for giving the certain answers to the question in a confident way. So I hope that you have understood the ray diagram, how I have obeyed the rule, and many things you have learned. And with this, I am ending the today's discussion. In next discussion, we will see some few new things in the geometrical optics. Goodbye.